Assalamualaikum and hi guys. In this video we're going to proceed with the next part that we have in implicit partial derivative, which is implicit functions. I believe that you guys are familiar with the terms implicit. We have learned one of the methods in finding derivative previously in the topic of differentiation, where you have implicit differentiation. That is where you want to find dy over dx, right, that have a function that consists of both x and y in it, right? So now that we have been equipped with the idea of partial derivative, instead of using implicit differentiation, we can solve for dy over dx by using implicit function, which is a lot more easier. Okay, so how to use this, right? We are going to solve for dy over dx by using this formula. So partial derivative of z over x over negative partial derivative of z over x over with partial derivative of z over partial y. Alright, so the equation will be consist of dy over dx. So how can we have z here, right? So we first, when we get the equation, the function, we'll first need to redefine it, right? So that we have z in the function. Now you have a function, okay. First, we will need to make it equal to 0, and later we will define that function as z. And after that, we will be able to find this two partial derivative and substitute it here to get the dy over dx. So let us first try to use the equation that that we have discussed before in implicit differentiation. You can have a look at the video of implicit differentiation before, right? Now, previously we solved this by using the concept of implicit derivative. Now we want to solve this by using implicit functions, which will use this formula. Right? Just want to show you how easy it is. So first, we'll need to rearrange this, redefine this in terms as z, right? Because z is equal to 0, so basically we'll just need to move all of them in one side. So for this one, we have 1 at the right hand side, so just move it to the left, so it becomes -7. So now all of this function is equal to 0, which is also equal to z. Now we have the function of z. Right, now that we have this, we can proceed to look for the partial derivatives. So a partial derivative of z in terms of x, right? So just conduct the partial derivative, right? So this is what you should get for x, and this is what you should get for y. Right? After you have these two functions, the next step will be to substitute it in this formula. So this is what you should get. Right, and to make to simplify it even further, right, because we have negative here, right, so this is actually what you should get, right? In just several steps, we can already find the dy over dx for these questions, the same question that we use to solve for dy dx in implicit differentiation, which is a lot more longer, right? So let's try a different question. Let's directly calculate for implicit differentiation by looking at exercise 5.3. Right, given these functions, evaluate dy over dx at 0.00. Right, so first let's find dy over dx for these functions. Okay, so as I said, first let's make it equal to 0 by moving 2 to the left hand side. So you'll get these functions, which is also equal to z. So now that we have z, we can start looking for the partial derivative. Alright, so we will look for these two derivatives. As you can see here, partial z over partial x equal to this, and partial z over partial y is equal to this. Now that we have this information, just substitute it in the formula of dy dx for implicit function. Okay. Right. So this is the functions, and now to evaluate it at 0.00, just substitute x0, y0 in all of the y's and x's that we have here, and that will give you -1. Right, that is for the first one. Okay, now for the second one, we have these three questions. Let's try to do it. Okay, so this is already equal to 0, so we can just directly apply the partial derivatives to obtain partial z, partial x, partial z, partial y. So this is what you should get. Right, so just substitute it in the formula, and this is the answer, the dy dx, the dy over dx for the first question. Right, it is simple, right? So now for the second question. Right, so as usual, change it into, let's make it equal to 0 by moving 2 to the left hand side. So this is what you get, and for this question it will be a little bit complex compared to what we have discussed in the previous questions, because as you can see, we have product here, x cos xy, right, and later y sin x. So to obtain the partial derivative of this function, we will need to use product rule. Sorry, for the first one only, right, we need to use product rule, because for the second one it is y times sin x. So for this one, it is considered as a constant in partial derivative, right? So we'll just ignore it, right? You just need to later conduct the derivative for this one. As for this one, we have x times with cos xy, where we have both x here. So to conduct to find differentiation for this one, we'll need to use product rule here. So x and cos xy, conduct a partial derivative in terms of x with respect to x. So this is what you get. So this is the partial derivative for the first one, right, where this is what I put here in the partial z over partial x. Right, y cos x is obtained from this. Okay, and for 2 here, we'll just ignore it, just put it out. Okay, and then we have partial z over partial y. For partial z over partial y, we don't really need to conduct any product rule, because we don't have y and y, right? It is x, so ignore it. We just derive this, and the same goes for this one. Only derive this one. This is considered as a constant. Okay, and this is to be ignored, and this is what I get. Okay, so now that we have the two derivative, the next thing to do is just to substitute it in the formula of dy dx and simplify it to obtain the answer. Okay, as for the last one, x to the power of 2 over 3 plus y to the power of 2 over 3 equal to a to the power of 2 over 3. So same thing applied, right? We need to make it equal to 0. So I will move a here to the left hand side to become this function, which is equal to z. Now that I have this, I can look for partial z over partial x and partial z over partial y. Okay, so this is what I should get, right? And I simplify it a bit, substitute it in the formula. Okay, so again I simplify it, cancel out which is able to be cancelled out, and that leaves me with this answer, y over x to the power of 1 over 3. So that is how simple to conduct implicit differentiation by using implicit function. Okay, thank you.